In the previous lecture of chemistry, we had learned about the different kinds of about the acids, bases, and we had started with the salts, and we discussed that the salts were those which were formed by the combination or partial or complete replacement of the replaceable hydrogen ions from the acid. So this way they are forming the salts by acid plus base, giving you salt plus water. We also described that the salt were of many kinds. One was the acidic salt having an H ion in it. Acidic salt. Normal salt will not be any kind of a hydrogen or a hydroxide ion in it. Then there would be a basic salt having a hydroxide ion in it. Double salt will be having two kinds of salts mixed together in it, like alum. Mixed salts will be the formation of two kinds of acidic molecules, or we can say the one which is like potassium, sodium carbonate, and things like that. And complex salts will be the one in which there will be complex materials like mixing saturated solutions of salts, simple salts together. So that is like tetramine, copper sulfate, and things like that. So in this way we saw the different kinds of salts. Now when we talk about salts, the most important thing about salts is whether the salt is a soluble salt or a insoluble salt, because depending upon the solubility of the salt, there will be the method of preparation of that particular salt. So if you are knowing that this particular salt is a soluble salt, then you know that it will be easier for you to use a particular method. And if you know that it is an insoluble salt, then automatically that will give you an idea that what should be the method used to make such a kind of a salt. So, or whether to use a particular salt for preparation of the salt or not, because it is soluble or insoluble. So accordingly, we have got this particular table of solubility of metals of metallic salts, wherein we see that firstly let us understand which are of the salts are soluble. Okay, so we'll take these ones which are soluble. So first of all is about soluble salts. So you have the soluble, and we'll have the insoluble over here. That will be, we can also consider it as an exceptions. So the first thing is that all salts of Na, K, or ammonium. So Na, sodium salt, potassium salt, and ammonium salts. So whether it is a ammonium carbonate or sodium carbonate or sodium sulfate or sodium chloride or potassium sulfate, potassium nitrate, any particular salt which has got the metallic ion as potassium, sodium, or ammonium, that is like this, in that case they are soluble. So all potassium, sodium, and ammonium salts are soluble. Okay, that's the first thing. The second thing is all nitrates soluble. All nitrates and nitrites. Okay, so any nitrate, if I take any nitrate or any nitrite, if I take calcium nitrate, potassium nitrate, sodium nitrate, aluminum nitrate, silver nitrate, silver nitrite, or let's say ferrous, that is iron nitrite, all these nitrites or nitrates, NO3 and NO2, if you have got any particular compound having over here NO3 or NO2 in them, they are 100% soluble. There is no exception. They are 100% soluble. These are 100% soluble kind of salts. Okay, so that is the nitrates. The next what we have is bicarbonates. So all bicarbonates. All bicarbonates are going to be soluble. Okay, so all bicarbonates are going to be soluble. So of course you have got only one particular thing, that the potassium and sodium bicarbonate are going to be sparingly, but they are soluble, but sparingly soluble. So here exception is there. Exception is that KHCO3 and NaHCO3 is sparingly soluble. Okay, sparingly soluble means partly soluble, not completely but partly soluble. That is sparingly soluble, that is bicarbonates. Then the next thing is all sulfates. What are sulfates? SO4. So all sulfates are soluble. If you take any sulfate, it will be soluble. But there is an exception. What is the exception? There are 4 compounds of sulfates which will not be soluble. One is PbSO4, that is lead sulfate. Next is silver, AgSO4, silver sulfate. The next is CaSO4, calcium sulfate, and barium sulfate. These are the 4 sulfate salts which are not soluble. So the exception is PbAgCaBa. Okay, PbAgCaBa. Okay, PgAgCaBa of sulfates are not soluble. Lead, silver, calcium, barium. Okay, so lead, silver, calcium, barium sulfates are not soluble. All other sulfates are soluble. The next are chlorides. So when you say next is chlorides, that is Cl, the one having chloride in it, the chloride will be Cl. All chlorides are soluble, but there are exceptions. What is the exception over here? The exception is again, Pb is again an exception. PbCl2 is an exception. Ag is also an exception. So Ag is common again here. Cg is not insoluble. Then Hg is insoluble. And finally is, so these are the 3. Pb, Ag, Hg. But here Pb is soluble in hot water. So here it is soluble in hot water. If I take hot water, then Pb is soluble. So as such, only insoluble chlorides will be the mercury and silver. Silver and mercury, AgHg. AgHg will be insoluble completely. But lead will be soluble in hot water, but it is insoluble in cold water. So if you take cold water, then lead chloride cannot be soluble. So we have over here that all chlorides are soluble, but PbCl2, AgCl and HgCl are insoluble. So these were all the salts which were soluble. So these were all examples of soluble salts. Got it? So we come again with the soluble ones. All potassium, sodium and ammonium salts are soluble. No exceptions except for this part, bisulfates, they are sparingly soluble. All nitrates and nitrites are soluble, no exceptions. All bicarbonates are soluble, exception will be potassium and sodium bicarbonate, which will be sparingly soluble. All sulfates are soluble, that is, exception will be PbAgCaBa. Okay, PbAgCaBa, PACB or P. I'm trying to make something which is going to help you to remember it. Anyway, it doesn't matter. PbAgCaBa. Okay. PACCABA. Okay, PACCABA. Take it, doesn't matter. So it is PbSO4, AgSO4, CaSO4 and BaSO4. All chlorides are soluble except for PbCl2, AgCl and HgCl, except for the fact that PbCl is soluble in hot water. Okay. Now we see the ones which are insoluble. So in insoluble over here, the first one is sulfides and sulfides. So we have got over here the insoluble part. All sulfide. Okay, all sulfides. Okay, all sulfides are insoluble. Anything having an SO3, insoluble. Having S only, insoluble. All sulfides and sulfides, sulfite, IDE and IDE sulfides, they are insoluble. But yes, exception क्या होगा? We know that these are the one which are all are soluble. So exception over here for this exception will be Na, K, and NH4. This will be the exception over here. This is exception. So all insoluble salts, what I will be writing, for all of them, the exception will be these three. So even if I say that all sulfides are insoluble, of course, potassium sulfite or potassium sulfide, sodium sulfide or ammonium sulfide, they will be soluble in nature because these are fully soluble. The next is all carbonates. All carbonates. So again, it will be CO3. So anything salt having a carbonate salt will be insoluble except again NaKn, NH4. So all carbonates insoluble. Next is all oxides. All oxides, that is O, will be insoluble. All oxides will be insoluble except for NaKn, NH4. Next is all hydroxides. All hydroxides, OH, again insoluble except for NaKn, NH4. So all hydroxides will be insoluble. And finally all phosphates. So all phosphates, that is PO4, will be insoluble except for potassium, sodium and ammonium. So we see over here that all these salts, all sulfides, all carbonates, all oxides, all hydroxides and all phosphates, all six of them, they all will be insoluble. So they will be completely insoluble in cold water. Okay, in cold water, none of these will be soluble at all. But out of these, जो metal like potassium, sodium, potassium and ammonium, if the salt of any of these are made up of sodium, potassium or ammonium, then it will be soluble. Like for example, ammonium hydroxide is soluble, potassium carbonate is soluble, sodium phosphates are soluble. So accordingly you see that if the cation present, that is a positive radical or the metallic part present in the salt is sodium, potassium or ammonium, then it is going to give you a soluble salt even for this 6 insoluble kind of salts. So here we see the end result over here, that all potassium, sodium and ammonium salts are soluble, all nitrites soluble, all bicarbonates soluble, all sulfates soluble, all chlorides soluble. Exception for bicarbonates will be potassium and sodium bicarbonate which is sparingly soluble. The exception for sulfates will be lead, that is PbAgCaBa. So that will be insoluble. PbAg NaCl will be insoluble, but PbCl2 is soluble in hot water. So this particular table what I have made over here is very important. You need to learn these by heart, because if you don't know this thing, the preparation of the salts will be difficult. Not only that, even in the later part when we are going to study the practical chemistry, there are so many different kinds of practical work to be learned, wherein you need to know that whether it is going to give you a precipitate or it is not going to give you a precipitate. So you will understand this thing by knowing that whether the precipitate which is going to be there is soluble, or if it is soluble then there cannot be a precipitate. If it is insoluble, only then there could be a precipitate. So for those purposes also you will require this table a lot. So this is a very important table which you need to learn by heart. Oh yeah, so that was about the solubility of metallic salts. Now we move on to the next part of the chapter, and that is the preparation of the salts. Okay. So it is seen that the salts are going to be prepared by 5 different methods, and normally it will be seen that a particular salt can be prepared only by one of the method. So that's why understanding each and every method and understanding that which salt will be using which method is very very important over here. So let's see the so we have over here the methods. The first one is neutralization. We very well know that neutralization is nothing but acid plus base giving you salt plus water. But neutralization is not just a single thing. There are of two kinds of neutralization. One is neutralization which is going to take place by using an insoluble base and an acid. So you need the base plus acid is going to give me water, salt plus water. But if I'm using the base, which is an insoluble base, then I'm going to use just a method of neutralization. Whereas if I'm using a soluble base, then the method of neutralization is called as titration. Okay, titration is a complete process. We'll be learning the process, or we'll be discussing the process in the later videos, because there is a complete procedure which we need to follow in the different kinds of the processes of making preparation of salt. So that we'll take up later on, but right now we'll just understand it as a different method of neutralization. So we see that neutralization, so in preparation of salt, the first one is neutralization. So in neutralization, the first kind of neutralization is the one in which there is insoluble base, plus acid giving me soluble salt plus water. So if I want to make soluble salts out of insoluble bases. Now what are insoluble bases? Pure base, not alkalis. That means oxides and hydroxides of metals other than potassium and sodium. Okay. So if I'm using anything which is oxide or hydroxide of copper, lead, iron, zinc, and then if I'm reacting with an acid, it is going to give me the respective salts with water. So we have the example over here as the examples with the kinds of the salts which can be prepared by this are given as CuSO4. The next is ZnSO4. The next is CuNO3 twice and PbNO3 twice. So you can see over here Cu. So this base which I'll be taking will be of course CuOH twice, right? Or I can even take CuO, so I can even take CuO, both are possible as bases. The acid, because I want CuSO4, the acid over here will be H2SO4, called CuSOH twice, or CuO plus H2SO4. This will give me CuSO4 by double decomposition. So CuSO4 and H2O will be given out. So 2H2O will be given out. Okay. So that was the first thing. Similarly over here, CuSO4 plus H2O. So this is the example of insoluble base reacting with an acid to give you soluble salt plus water. Now, again, we had learned CuSO4, all sulfates are soluble, hence it is a soluble salt. Got it? You can see over here we are not taking the example of PbSO4 over here, we are taking PbNO3. Why NO3 we are taking and not SO4? because SO4, PbSO4 is insoluble, so we cannot prepare it by this method. Okay, so we have over here as the next one is PbO plus NO3, so it will be HNO3 acid to give maybe PbNO3 twice plus H2O, right? So this will be the formation of PbNO3 twice. You can also have PbOH, so PbOH twice plus HNO3 giving me PbNO3 twice plus H2O. So you can see we have got this particular thing. For this also the same thing, ZNO plus H2O SO4 will give you ZnSO4 by H2. For this one it will be CuOH twice plus HNO3 will be CuNO3 twice plus H2O. So same kind of reaction will be there. So this method is for sulfates and nitrates, that is sulfates and nitrates of insoluble bases. Okay, so the metals which has got an insoluble base, if I am making the sulfates or nitrates, because I know that sulfate and nitrates are soluble, so if I am preparing a soluble salt using an insoluble base, then the process which I'll be using is called as titration. It's called as neutralization. The same neutralization can also be done with the help of other method, and that is called as titration. So titration is a process, also a kind of neutralization. In fact, it is neutralization, but only the procedure of neutralization is different. That's why it is called as titration, which is a kind of a lab post process in which we are taking, instead of taking an insoluble base, we are taking a soluble base plus acid to give me soluble salt plus water. Okay, so it is going to give me soluble base plus acid, give me soluble salt plus water. Soluble base, we have got a very few amount of soluble bases, that is only potassium, sodium and ammonium. So we can have, so what we can see is that the only kind of the salts which I can prepare with this one are the one having K plus, Na plus and NH4 plus. Only those salts having potassium, sodium or ammonium in them can be prepared by the process of titration. Remember this thing, titration can be done only to those processes where the hydroxide or oxide is a alkali. Okay, it is not a base, it's a base but also an alkali, that means it's a soluble base. Accordingly, we have only potassium, sodium and ammonium which is possible to be made by this particular process of neutralization. Accordingly, we see the example will be NaOH over here, so NaOH plus we can say HCl, giving me over here NaCl plus H2O. This is one example. You can have another example of NaOH with HNO3 to give me NaNO3 plus H2O. So that's a potassium nitrate, sodium nitrate and sodium chloride being formed by the process of titration. We can also prepare some carbonates using the same thing. So carbonates also can be given out by the same method, that is okay, sorry, not decompose, it is, you can use, instead of using a soluble base, you can use a soluble carbonate to using this particular things, because we know very well that in acids we learned that a carbonate, when it reacts with an acid, okay, we have learned in the acids part, if you remember, if you can recollect, or you can just go a few pages behind, you will find that when a carbonate, that is the third reaction, that when a carbonate or a bicarbonate reacts with an acid, it will give you a salt plus water plus carbon dioxide. So this is also a method by which you can produce a salt. So that's why we have over here that it could be Na2CO3 plus H2SO4 giving me NaHSO4, or it could be Na2SO4 also, so I can take Na2SO4 also. Both the things are possible depending upon the temperature, and then it is going to give me as H2O plus CO2. So that's we give, hence we get this particular thing over here. So accordingly we see that carbonates, or we can say metallic carbonates of sodium or potassium or ammonium, can also give me the salts of the potassium, sodium or ammonium. Okay, so that was the second kind of a method. So this was the first method, neutralization. The second one was titration, also kind of neutralization. Neutralization was taken care by the insoluble bases, so that's why we have taken CuSO4, ZnSO4, CuNO3 twice and PbNO3 twice as the kind of salts which can be prepared. Titration is only for potassium, sodium and ammonium salts over here, so hence we are getting over here as acid plus base plus acid equals salt plus water. We can also prepare by the carbonate salts, the carbonate salt of potassium and sodium with reacting with the acid to give you Na2SO4 plus H2O plus carbon dioxide is going to be given out. So that was the second thing. Now we move on to the third method, is simple displacement. So the third method we'll discuss in the next video. So we stop here.